Welcome to my lecture video on testing two means when sigmas are unknown, which means I have the sample standard deviation given instead of the population standard deviation. So basically, when you looking at the exercise, um, here you see it says sample standard deviation, so 2.4 in reality is S1 and 2.5 is S2. Obviously, these are the mean scores, so this is x1 bar, this is x2 bar, and this is n1, and this is n2. All right, let's see what it says. One group of math students took a distance learning class, while another group took the same course in a traditional classroom environment, and the following sample data was collected. So what we want to know is that whether there's a significant difference between the mean scores between the two groups. So basically, we want to know if the average of the first group is equal to the average of the second group, or is there a difference, which means it's not equal to. So basically, that's what we're testing here. And of course, I have all the information given to me there, and I know my significance level alpha is 0.05, which is basically all I need for this exercise to begin. All right, so as always, we'll start with setting up our null and alternative hypotheses. So step one, so my null, my alternative, and as I've told you before many times, we always start categorization with allocation to the alternative hypotheses. And the inequality always goes to alternative hypotheses. So H1 will be, sorry guys, so H1 will be mu1 is not equal to mu2, and HO will be mu1 equals to mu2. So, and that becomes my step one. All right, step two is a test statistics. I'm testing two means and sigmas are unknown. So for this, I will take you to Excel because this is done purely on a spreadsheet. So I have it already typed up. I have this table typed up on a spreadsheet so we don't waste a lot of time. Well, it looks like an octopus here, but a lot of legs. But I did this so you guys could see that x1 bar, s1, and n1 with red arrows. I've told you where they exist in the formula, and where the second set of numbers exist in the formula with green arrows. And I've also shown you that mu1 minus mu2 is always 0. So given that, now I could type the test statistics. Okay, so you could take a picture, image of this because I'm going to erase it. So let me first erase all these lines so that you could just focus on the formula I'm typing. I did this so you could see what goes where. All right, so I'm going to erase all this and let's start typing the formula here. So I'm going to say equal to, and basically I'm typing the formula below me, x1 bar minus x2 bar. You don't need to type minus 0, so divide by the square root of, and you don't need any parentheses here, just click on tap on s1 squared, divide by n1, plus s2 squared, divide by n2, and that is my test statistics. So the response is negative 23.715. That's it. That's a very, very small, that's a deep in the rejection region test statistics. We just know by rule of thumb that if the test statistics we calculate is a huge, huge positive number, or if it's a huge, huge negative number, then it's definitely in a rejection region. So that's just the common sense that you should have on this topic. Anyway, so my rejection region is my test statistics is negative 23.72. So let me go back to my lecture. So the test statistics is negative 23.72 again. So over here, if I scroll down, so my test statistics, which is going to be T, is negative 23.715. So I'll just use one decimal place here. So there is my step 2. My step 3, as you recall, which is always the same, is the graphing section, the graphing step. So here I draw my distribution. Okay, I decide if it's a left tail, right tail, or two tail. Here H1 is not equal to, so it's a two-tail test. It's a two-tail test. I'm going to do my rejection regions in red. go. This one in red too. So here's my the two rejection results because it's a two-tailed test. Excellent. So there is my rejection region. All right. Now it tells me that my alpha value is 0.05. So alpha is 0.05. That means the area in both tails. Because remember, alpha is the total red area. So if you only have a one-side red area, then that's alpha. But if you have a two-sided red area, then both of them are alpha. So the area, I'm just going to write it in both tails, is 0.05. Which, if you wanted to know, well, you don't need to, but if you wanted to know how much is in each tail, you just divide 0.05 by 2. So 0.05 divided by 2 is in here, 0.05 divided by 2. And I've told you this before, but I'm just going to mention it again here. A lot of y'all wondered if when they write z alpha over 2 as to what that means. I mean, here is exactly where I could show you what it means, why it's notationed that way. The reason they write z alpha over 2, because if it's a two-tailed test, and if you recall, I told you that most tests, hypothesis tests in research are two-tailed. So if it's a two-tailed test, then whatever alpha is, the amount of area in each tail is always alpha over 2. And that's what this is. So that's why they kind of write the z-score, even though it's actually reversed, because the z-score is always based on the area to the left. But somehow they labeled the z-score based on the area on the right. It's kind of weird. But it is what it is. So that's what alpha over 2 is. That just refers to this upper tail area. And that's why they write z alpha over 2. Or you've also seen t alpha over 2. Anyhow, so I just wanted to mention that it's irrelevant to our calculations, but it came up, so I may as well just tell you here. So anyhow, this is a t-test, obviously. Because of the fact that the population standard deviation is not given. That's one reason, but if you don't notice that, it's a t-test because that says t. So in both layers, at both areas, you could determine it's a t-test. Which means these two critical values are going to found using the t command. And you recall that's t dot inverse dot two tail. And here you put the area in both tails. And if it's a two-tailed test to begin with, as I've told you before, you don't need to multiply it by 2. It's already the area for both tails. So the area in both tails here is 0.05. I don't need to multiply it by 2. And my degrees of freedom, remember, is always the smaller of the two n minus 1s. So the first n minus 1 is 39. The first n minus 1 will be 39. The second n minus 1 will be 49, and of course 39 is smaller, so we're going to go with that degrees of freedom. So my degrees of freedom is 39, and that's the one I'm going to use. So let's go ahead and use the 39 degrees of freedom here. And if you type that on a spreadsheet, you'll get the critical values. The critical value will be 2.0227. Of course, you don't need to write all of this, negative 2.0227. I'm just writing it so you know precisely what you're going to get when you type that command. And to be honest with you, I'll just write this as 2.02, and I could write this as negative 2.02. So there we go. So 2.02 and negative 2.02, and now that's step 3. So now I'm about to do step 4, which basically I have to figure out my decision and my conclusion. Now, we've practiced this many times by now. The decision had to do with whether the test statistics falls in the red area or not, and here it obviously does. So the decision will be to reject the null hypotheses. Reject the null hypotheses, which means you're rejecting the fact that the averages are equal. So you go and look at my flowchart for this, and if you're rejecting the null hypotheses in a 2-population test, you're basically rejecting the fact that the averages are the same. Basically what you're saying is that people that are taking distance courses and people that are taking traditional courses, their average grades are not the same. Now this test doesn't tell you which one's better. For that you need to do other tests, but all this test does, it tells you whether the averages are the same or not. And here you're rejecting the fact that they're the same. So proper conclusion will be there exists a difference between the two. So the proper language is there seems to be a significant difference between the averages or the means. And that's it. That's the end of the four-step hypothesis testing procedure for when you're testing two means and sigma is unknown. Thank you.